In this video, I'll be making some Disney pattern rings using some of the same techniques I used to make my other Disney bowl projects. I'm starting out by using these ring inserts that I got from craft supplies. I made these two prototype Disney pattern rings from some of these scraps left over from my miniature Disney bowl project in order to test out the methods and determine what would need to be modified to produce these small Disney pattern rings. My first observation is the layers need to be rotated more than was done in these scrap pieces from the miniature Disney pattern project. Secondly, I think the layers need to be thinner. When I made these rings, each of the rings only contains 3 layers, and each of these layers was about 50,000 of an inch thick. However, for these rings, I will be cutting the rings between 25 and 35,000 of an inch thick. I'm going to start by producing 2 laminated boards. Each of these boards will be about 1 3/4 inches wide by 15 inches long. For this first board, I'm using thin boards that were sliced on the Accu-Slice system that vary in thickness between 25 thousandths and 100,000 inch thick. Again, boards of different colors and contrast. A total of 21 of these boards will produce a finished board that will be about 1 inch thick. For the second board, I'll be gluing up thinner boards that were once again sliced on the Accu-Slice system. These boards will vary in thickness between as thin as 10 thousandths of an inch thick up to 40 thousandths of an inch thick. A total of 35 wood strips will once again be glued up to produce a board that will be about 1 inch thick. Once again, I'm using the glue jig for my glue up, using the West epoxy system, and I mixed up a batch here already, and I find the best way to apply the epoxy to the boards is with a paintbrush. After epoxy has been applied to all the board surfaces, the assembled boards are realigned and inserted into the wax paper liner in the glue jig system. A series of C-clamps are then applied to the glue jig rails to clamp the laminate strips together and squeeze out the excess epoxy cement. I allowed my 2 laminated glued boards to dry overnight, and I just took them out of the glue jig system. And now I'm ready to take these to my joiner planer to clean up the edges and then run them through my board sander to get the surfaces nice and clean. And then I'm ready to start cutting out my round disc. I marked on my disc that I'll be cutting out from this board. I said they're about a little over 1 inch in diameter. And what I did is I cut the outside first of this, and then I took it on my belt sander and sanded it smooth. These pieces are so small they're hard to handle, and your fingers are pretty close to the blade and also close to the sanding disc. So by sanding this first on a bigger board is just much easier. I only have to sand half of it, getting my fingers closer to the sanding disc. And when it comes off, this is what it looks like after it's been sanded. I'm using the 10 teeth per inch squirrel saw blade to cut the disc. And then I'll finish sanding this right to the line on the either disc sander or the belt sander. Now because this piece is so small and there's so much glue in it, if I were to sand out here on the disc, it gums it up pretty quickly. By sanding on the inner surfaces, it doesn't gum up. It goes a little bit slower speed, doesn't gum up quite as quickly. When I cut these laminated rods on the scroll saw, I cut just outside the scribed circle line. I then sand the laminated rods to the circle line. My disc sander table is perfectly square to the disc sander table. They're from my sanded laminated rods will have perfect, straight, and parallel sides. I have my round pieces all cut from my laminate boards, of my two different styles of laminated boards, and now I'm ready to glue them up that I can slice off my thin layers on the Accu-Slice system. And I'm going to be using my new low profile carriage. This is a new carriage we just made recently. Instead of being 4 inches high, it's only 2 inches high. And for these small pieces, it'll be a much better way, easier way to cut these boards. I'm using Type-On 3 glue to glue the laminated rods to the sacrificial fence, and then allow them to dry for 2 hours. I mounted my sacrificial fence to my low profile carriage with my two disc on it, and I made a few modifications to the bandsaw. Since these pieces are so small and so thin, I didn't want them getting jammed down in the kerf slot on the bandsaw, so I used some tape to close that down to get it as small as possible, so they shouldn't jam in there and get caught up. So I trimmed it off. Now I'm ready to start cutting my boards. So what I'm going to be doing here is 1 full revolution for the kerf of the blade, and let's try 25 thousandths as a starting point. Because I closed up the spacing around the bandsaw blade, the bandsaw vacuum system did not work quite as well, and a lot more sawdust was generated on the top of the table. This did result in excessive sawdust getting into the roller bearings on the carriage. I just finished cutting these thin laminated discs from these laminated wood strip rods. Each of these discs is 25 thousandths of an inch thick. Next, I want to glue these laminated discs back together, rotating each one a slight amount to get my dizzy pattern for this project. However, after I slice these discs, I realized that there's going to be a problem in attempting to glue the discs back together to keep them properly aligned and keep them from slipping and sliding in the clamping process. In my past dizzy projects, I used these jigs made from a piece of MDF with metal dowel pins to keep the disc aligned as I was gluing them. This process worked quite well for the larger laminated disc. However, this technique will not work for these small discs. There's just not enough room for the spring clamps in the glue-up process. Even if I use these small 1/8 inch diameter pins, there's still not enough room for these clamps. This is a new glue-up jig that I'm using to glue and align my laminated disc so that they don't slip and slide during the glue-up process. I made these jigs from a 1 1/4 inch Delrin plastic rod. I cut off 1/2 inch thick disc from this large Delrin rod and then drilled a 3/8 inch diameter hole through the center of the disc. I then inserted a 3/8 inch diameter by 1 inch long metal dowel pin in the Delrin disc. The hole in the second Delrin disc was drilled slightly oversized so that it will slide easily over the metal dowel pin. I'll then use this second Delrin disc as a top plate for the clamping of the disc together. I then drilled a 3/8 inch diameter hole through the laminated wood strip rods and then used a reaming tool to clean up the drilled hole to make sure it was precisely 3/8 of an inch in diameter. I'll next slice this laminated wood strip on the Accu-Slice system to produce these 25 thousandths inch thick laminated discs with a 3/8 inch diameter hole in the center. These discs can then slide onto this Delrin jig to enable the gluing up of the disc and permit me to properly align each set of the disc in the proper position, and then I can clamp these to ensure that they are properly aligned. One other technique that I've done is I use a black marker to scribe a line the entire length of this laminated wood strip rod. This line should be on this edge of this wide wood strip here, but slightly off center. The black line is used to ensure that you align the disc in the correct position when regluing, that you not glue any of the disc on upside down nor rotate it by 180 degrees. Because I'm aligning and gluing very small laminated boards and disc, even the smallest misalignment will be noticeable. It's possible that the hole in the center of the laminated wood strip rod may not be perfectly centered, or maybe this left and right hand laminated boards are not precisely the same. Variations of less than 5,000 of an inch are very noticeable. By using this black indexing line, this will enable you to make sure the discs are glued back in the correct orientation from which they were sliced from this original laminated wood rod. And you can compensate for any misalignment or variation that might exist. Let me start by demonstrating the drilling of the holes in these laminated wood strip rods. I'm using my mini metal lathe to drill the holes through the center of these laminated wood strip rods. And I've mounted my wood strip rod in my 3-jaw chuck, and I've attached a 3/8 inch diameter drill in the tailstock. I could have done this on the wood lathe, but I think this lathe is more accurate than my wood lathe. So next I'm attaching a 3/8 inch reamer, because it's important that this hole be exactly 3/8 of an inch in diameter, so it slides, easily on that 3/8 inch metal dowel pin, but with very little slop. So I want a very accurate hole in this. So now I'm ready to cut off my disc on the Accu-Slice. Because the sliced discs are so small and thin, I'm using a pair of tweezers to grab the disc as the cut is finished. This prevents the sliced disc from flying away. It also helps minimize the small burr left on the edge of the sliced disc. Well, I'm ready to start gluing up my thin disc. And this is one I've completed. And what I'm trying to do is get my layers such that they rotate around 45 degrees. This is one that's already been glued up and it's dry. So there's a total of 11 layers in here, a little over 1 inch in diameter, with this 3/8 inch spacer through the middle. So this is my jig. Consists of this dowel rim base with a 3/8 inch pin, and I'll stack my disc on here, one at a time, glue them up, then a spacer goes on top to clamp them together. And what I showed previously, when I cut these on the bandsaw, I did put a mark on one side to get the orientation exactly the same on all these discs. So it's off this wide piece, slightly off center. And these aren't quite aligned, but when they're aligned properly, they'll get a 45-degree rotation. And to get this angle, what I'm doing, I'm looking at this center red piece of red heart, and I'll be rotating that the exact width of that segment every step. And you can kind of see that in this piece, where that center piece is rotated exactly the width of the segment. And that'll give me approximately a 45-degree angle. Gluing this is tricky. I'm using a magnifier, putting one layer at a time, applying glue, and then aligning it and using a stick to remove the excess glue so I can see my black line and make sure I get it the right orientation, and then get my correct orientation for this center red line. I begin the glue up by coating one surface of the first disc with Type-On 3 glue, and then inserting the disc onto the glue up jig. Glue is applied to a second disc, and the disc is added to the glue up jig. The orientation of the black lines is noted to make sure that the discs are added in the correct orientation, and then the second disc is rotated to the correct angle by positioning the edges of the center red heart wood strips in the disc. The top dowel rim disc is inserted onto the center dowel pin, and the two dowel rim discs are lightly pushed together to force out any excess glue. The alignment of the disc is double checked, and if the discs have moved, they are realigned by rotating the top disc. The process is repeated for 5 or 6 of the remaining discs, coating each surface with glue, adding the disc to the glue-up jig, and then aligning the disc as needed. Use care to make sure the black lines appear in the correct orientation. After lightly using finger pressure to clamp the disc and remove the excess glue, recheck the alignment of all the discs and realign as needed. Use a small wood stick or paper towel to remove the excess squeezed out glue so that you can more easily check the alignment of the disc on the glue-up jig. Then apply some spring clamps to clamp the disc together. This will squeeze out some additional excess glue, which should then be removed to enable you to check the alignment of the disc. After allowing the glue to set and dry for about 5 minutes, the remaining 5 discs are added in the same manner to complete the assembly. After all the discs have been added and aligned, clamp the disc assembly using 2 or 3 spring clamps. Remove any excess glue and verify the alignment of all the discs. Allow the disc assembly to dry for at least 10 minutes before proceeding to the next step. One thing I do more, I have my piece glued up here and I want to get rid of my center pin before it glues in there solid. So I just have a piece here with a hole in the center and a jig, and I'll just press it out. I normally place the disc assembly back into the press and allow it to dry overnight. I'm cutting these laminated discs for these rings on my metal lathe, and I'm doing it for 2 reasons. Number one is this blade goes in perfectly straight and parallel, so my side will be perfectly straight and parallel in the finished product. The other reason is I can index this in thousandths of an inch, so I can go in incremental, very small increments to get a very, very tight fit on my ring. When I get close to the final size required for the metal ring insert, I increment the lathe cutter in 1/1000 of an inch increments until the metal insert fits properly. I'm ready to glue my metal inserts into these layered rings, and I'm using epoxy. And the epoxy I'm using is this called G-Flex epoxy. It's the same epoxy I use for my knife handles. It's a 1-to-1 mix. The epoxy is mixed in a 1-to-1 ratio. After thoroughly mixing the epoxy, both the inside of the disc assembly and the outside of the metal insert are coated with the epoxy, and then the metal insert is slid into the disc assembly. The remaining rings are assembled in the same manner, and then the glued assemblies are allowed to dry and cure overnight. This is a simple jam chuck I made to put my rings on to turn them, and it's turned down. There's a little bit of a lip here, so it keeps the ring nice and straight on the mandrel. So I just push it on. It's a tight, snug fit, and I can turn it on there. I'm using a square carbide cutter to shape the rings. The 90-degree sharp edges on this cutter enable me to shape the inside edge of the ring on the mandrel. After I finish shaping the ring, I then begin sanding the ring, first starting with 320 grit sandpaper, then 400 grit sandpaper, followed by a finish with steel wool. This is a mandrel I got from Craft Supplies. Just mounts on the headstock here and has some spacers. You put your ring on here and centers on these bevels on these spacers. And this is the first time I'm trying this, so we'll see how it works. One of my concerns is not a lot of space to get down there close to the metal sleeve. Once again, I'm using the square tip carbide cutter. Both the 90-degree corners on this tool enable me to cut down into the corners on both sides of the ring. Again, I finish with 320 and 400 grit sandpaper, followed by a steel wool cleanup. This mandrel assembly from Craft Supplies worked very well, and I'll be using it for the rest of my rings. In finishing these rings, I first of all sanded them on the lathe with 320 grit sandpaper, then 400, and then steel wool, and I'm finally doing a buffing with some of this white compound. And that cleans it up quite nicely. Then I'll give it a couple coats of polyurethane to finish it. These are the finished rings made from the two laminate boards. I made ring sizes ranging between size 6 and size 10. These rings were made by rotating each of the 11 layers in the same clockwise rotation. These rings were made by rotating the first 6 layers in a clockwise rotation, and then the final 5 layers were rotated in a counterclockwise rotation. The resulting heart-shaped pattern is unique and was not expected in my initial planning.